Alright, this is probably one of the harder sections we're going to do because you really have to think about what you're trying to find and how you can get that. All the shapes we're going to look at today are going to be shapes we can't find the area of directly, so what I'm going to do for every problem is first write out in words what we can do to find the shaded part that they're asking us for. So you have some directions at the top for this first one. What they're asking you to find the area of is that little teeny tiny piece that's shaded. But we don't have a formula for that. What we call this in math, we call it a segment. But we can't find the area of the segment directly. So what we can find the area of is I can find the area of the whole sector. So we're going to do the area of the sector. And then I can find the area of the part that's not shaded in that sector. The part that's not shaded in the sector is the triangle. So we're going to do the area of the sector minus the area of the triangle, and that will give me this section that's just shaded. So to find the area of the sector, I've got to use its formula. Its formula is the measure of the arc, which is 90 over 360, times, we're talking about area, so I'm going to use the area formula here, pi r squared. So this is just like what we did yesterday. I'm typing in 90 divided by 360 times 8 squared. And that gives me that this is 16 pi. And then we also have to find the area of the triangle. Now to find the area of the triangle, we have to go back to the beginning of our chapter. There were a couple different triangle formulas. This one has a right angle, so we're going to do 1/2 base times height to find the area of the triangle. The base I know is 8. You have to make a little bit of inference about what the height is going to be. The height, because it's a circle, all radii in the circle are the same. So that is also going to be 8, because that's still reaching out to the edge of the circle. So they're both going to be 8 here. So that's going to be 1/2 of 64, which is 32. And then we said to find the area of the segment, I have to take those two answers I got and I have to subtract them. This is where I need you to be super careful how you do that. One has a pi and one does not, so you cannot subtract them from each other. You can just type that whole thing in your calculator because all directions here will ask you to round to the nearest tenth. So you're just going to type in 16 pi minus 32. I am putting the pi in because we want to round to the nearest tenth. And we'll get 18.3 is what it bumps up to feet squared. Okay? Alright, let's try number 2. Number 2, we're looking for the area of this little section. It's hard to see, but that's what's shaded right now, that little purple section. So we got to think about what we can find the area of to help us. So if we do the bigger section first, the bigger section would be the area of that sector. The area of that sector would be its measure, 60 degrees over 360, times pi times the radius is 6 squared. So the area of the sector ends up being 6 pi. And then we also need the area of the not shaded part inside of that sector, which is the triangle. So to find the area of the triangle, I have to think about what kind of triangle that is. This time they did not give me a right angle. I don't have a base in the height, so I freeze for a second. But then, if we pay attention, that is 60 degrees, and this would be congruent because it's a circle and the radii are the same, which means this is actually 60, 60, 60, which means this is not just a regular plain old triangle, this is an equilateral triangle. So we have to go back to the beginning of the chapter and use that special equilateral triangle formula here. This is going to be side squared radical 3 over 4. I'm going to get 6 squared radical 3 over 4, which is 36 radical 3 over 4. And that gives me an answer of 9 radical 3. So now to find the segment, the part that we wanted, we have to subtract those two. 6 pi minus 9 radical 3. Those cannot be combined the way they are, so I'm just going to type them in my calculator. If you want to make them decimals first, you can, if that helps you. But I'm just going to type them just like that in my calculator, and it tells me that that little itty bitty section is 3.3 meters squared. Okay? Alright, number 3 is different because there's more that's shaded here. This one actually has this whole, if we break it apart, it has this whole sector that's shaded. So we're going to have to do the area of the sector. But it also has that the triangle is shaded. Everything's shaded except for that little itty bitty section. So we would also need to find the area of the triangle, but look at how this one's different. Those are both shaded. Those are both shaded. We don't need to subtract anything this time because we're not taking away any empty space. We're going to add those two together to get our final answer. So for the area of the sector, I'm going to do the arc length of the sector, which is this bigger section, is what's shaded. So it's not 60. We have to do 360 minus 60, which is 300. So that's 300 over 360 times pi times the radius squared. That's our sector formula. So it's 300 divided by 360 times 12 squared. This is 120 pi. And then we have to find the area of the triangle. It again has a 60-degree angle, which means that it's an equilateral triangle. So we're doing side squared radical 3 over 4, which is going to be 12 squared radical 3 over 4, which is 144 radical 3 over 4, which is 36 radical 3. So then to find the shaded part means I need to add those together because they are both shaded. There wasn't anything that was unshaded this time. So we're doing 120 pi plus 36 radical 3. I'm typing that exactly as it looks on my screen into my calculator, and you should get 439.3, meters squared. Okay? Alright, this last one, we are looking for the area of the shaded region, and it's these weird shapes. Again, all of the things we're going to look at today, we don't have a formula because it's a weird shape. So we need to look for the things that we do have the formulas to find the area of. I see in this picture, on the outside, I see a square. So we're going to have to find the area of the square. And then the other shape I see are these two half circles. And I want you to imagine if we put those two half circles together, wouldn't they make one whole circle? So instead of doing them separately, I'm going to pretend like they're together even though they're separate. And I know I need to find the area of one whole circle in that picture. Now because the circle is not shaded, we have to subtract to get our final answer here. So now we just have to find these areas. The formula for a square is area equals side squared. So that's just going to be 8 squared, which is 64. And then for the circle, area formula for a circle is pi r squared. And the radius, just be careful, the 8 was the whole side of the square, so the radius would be half of that. The radius is going to be 4. So it's pi times 4 squared, which is going to be 16 pi. And then we have to subtract. Just make sure you're doing what it says over here, that you're doing the outside shape minus the inside shape. So the outside shape was the square. So it's going to be 64 minus 16 pi. Again, you cannot subtract the 64 and the 16. You've just got to type that exactly like that in your calculator. Don't try to combine them. Just type it in. Should get 13.7 feet squared. So there's 2 problems for you to try on ClassKick. If you have any problems with them, please contact me on Hangouts or raise your yellow hand. But if you don't hear from me right away, contact me on Hangouts and I will help you through any of the problems you're struggling with. And then you just have a short homework assignment to try some of these tonight. All right, good luck, and we will be reviewing tomorrow.